Welcome. In this video, I'm going to go over how to find the equation of the tangent plane to this surface here at this specified point. First, recall that the equation of the tangent plane to a surface at a point is given by z equals the function evaluated at that specified point. In this case, two variables, x naught, y naught, are the inputs. To that, we add the partial derivative with respect to x evaluated again at this point times x minus the x value of the corresponding point. And please bear with me while I shift this over since I seem to not have allowed myself enough space. And then we add the partial derivative with respect to y evaluated again at the same point times y minus the y value of that point. So first, let's go ahead and evaluate f at -1, 3. That's -1 cubed minus -1 squared times 3 plus 3 squared minus 2 times -1. Oh boy, I seem to not be managing my space very well right now. There we are. Okay, where was I? I was here. Now to that I'm going to add 3 times the y value, which is 3, minus 2. And this works out to be, pause your video and try to work this out. All right, you should have paused your video and obtained a value of 14. Okay, so that's this portion here. Next, let's evaluate, or let's obtain the partial derivative with respect to x. So the derivative of x cubed with respect to x is 3x squared. The derivative of negative x squared y with respect to x is negative 2xy. The derivative of y squared with respect to x is 0. The derivative of negative 2x with respect to x is negative 2. And then these last terms vanish since the derivative of both of these with respect to x means they are treated as constants, and we end up with 0. Now, the partial derivative of f with respect to x evaluated at -1, 3 is 3 times -1 squared minus 2 times -1 times 3 minus 2. Please pause your video and evaluate what this works out to be. Okay, you should have paused your video and obtained a value of 7. So that is this portion here. Okay, now let's work out this portion by first finding the partial derivative of f with respect to y. So x cubed is treated as constant, so it vanishes in this derivative. The derivative of negative x squared y with respect to y is just negative x squared. The derivative of y squared with respect to y is 2y. Negative 2x will vanish, as will negative 2. Both of these are treated as constants. And then the derivative of 3y with respect to y is 3. Okay, so now we can evaluate the partial derivative of f with respect to y evaluated at -1, 3. That's equal to negative 1 squared plus 2 times 3 plus 3. Again, please pause your video and work this out independently. You should have paused your video and obtained a value of 8. Okay, so that tells me that the tangent plane to f at -1, 3 is z equals 14 plus 7 times, now that's this portion here, x minus -1 plus 8 times, and this is this portion here, y minus 3. Distribute and simplify this to get 14 plus 7x plus 7 plus 8y minus 24. And this works out to be z equals 7x plus 8y minus 3. Now, before I end this video, I want to show you what this looks like when graphed in GeoGebra. So let's go ahead and type in the letter F, and then open parenthesis x, comma, y, close parenthesis, equals x cubed plus, oh, excuse me, it's minus x squared y plus y squared minus 2x plus 3y minus 2. Okay, and I'm going to rearrange this a little bit. We're looking at the value of -1 for x. Y is 3, so we're right around here. And the z value is 14, so I'm going to have to shift this graph a bit. Let me go here to Tools, to More, and scroll almost all the way down to Move Graphics View. And I want to move it this way. In fact, I want to try to squish it. And that can be kind of tricky in the 3D view, at least for me. Okay, so I took my thumb and middle finger and pinched the z-axis inward, and then I did something similar with the y-axis to try to get a better view. And I'll go back to rotate. There we go. So now I'm going to type in the ordered triple -1, comma 3, comma 14. There it is. And here's that point right there on our curve. You can see it does lie right on it. And finally, I'm going to show you the tangent plane of z equals 7x plus 8y minus 3. And there is our tangent plane. And actually, let's change its color a little bit just to make it a little clearer what we're looking at. Okay, and for this one, I'm going to dim it a bit, change the opacity a bit. There we are. All right. And I'll zoom in and you can see that this plane is certainly tangent here. It looks like a two-dimensional tangent line when looked at directly above the plane. And you can tell it is tangent to the curve at this point, -1, 3, with a z value of 14. Those of you in my class, I do expect you to use technology, use GeoGebra specifically throughout the semester, and hopefully you will avail yourself of this technology to ensure that you understand the material and can check your own work. All right, hopefully you found my little video here useful. Please keep calm and math on.